Now with the lightning talk session, as soon as the projector wants to turn on. So, well, our first speaker is called Zishan. Okay, it's hard for me to pronounce it. In Spanish, this is read Tesanali.
Okay.
And he's going to tell us about what's in the boxes. So as soon as, oh, yeah, now it can. So as soon as it starts, we are welcome to go. Can you hear me?
No?
So you're going to get 10 minutes, and at 9 minutes, I will shout, and at 10 minutes, we're going to just grab the microphone. And this is for all the speakers.
I'll just keep the microphone just for the fun.
Okay. All right.
Okay. Should I start now?
All right. So.
Okay. Hello. As you heard, my name is Dishan Ali. I'll talk about something called boxes. It's GNOME 3 application. GNOME 3, if you don't know, it's a desktop environment. It's a really cool one. Looks really cool. This project is about management of machines, other machines. Other machines is a general name we just use for two types of machines, the virtual machines and the remote machines. Virtual machines, a virtual machine. And remote one is a remote desktop display, for example. So if you have a machine somewhere else, you want to connect to its display, you can use boxes for that. And also you can use boxes for connecting to a remote virtual machine. So you want to connect to the whole machine, like you want to manage it, you want to be able to create, destroy, delete machines in a remote location. So that's also possible. We don't support virtual remote because it's not a thing. It's written in Vala. I presented about Vala since you missed the talk, so you wouldn't know what I'm talking about right now. The application is designed to be very simple and elegant, just like all the GNOME 3 applications. As a proof, I'm providing a screenshot. As you can see, pretty simple. It's a bit stretched in the screenshot somehow, but that's how it looks like. You have multiple of your machines. The first one you can see is a remote machine. In this case, local, but yeah, it will appear like that. You can also get screenshots for those, but somehow I didn't have it for this machine. And for the rest are virtual machines, so you can at the same time run multiple operating systems on the same machine without using dual boot or multi-boot. That's the main use case of virtual machines nowadays, and boxes can be used very effectively. It's one of the main things about it is that it's really easy to create machines. We have something called express installation, which means that you click a few things and then it creates the machine for you with all the right defaults. And we have support for these OSs, and more has been added and more will be added. I can't go further. That's how you do create a machine. It finds all the ISOs you have and stuff, and it presents to you. You click on something, it then download device driver and sets up in other ways. You ask you a few things if you want to enter them. Some things are mandatory. For example, product key in Windows is mandatory, so it doesn't let you go forward without that. Another thing is USB redirection. If you have USB stuff in you have the USB port in your machine, of course, and you want to use the USB device in your virtual machines, so we support that. You can use boxes to do that. And you can choose in the options menu which ones to import, which ones to export. There's something called overt, which means that it makes it easy to manage remote virtual machines, and we support that in boxes. You can ask me later what it is. It's a complicated thing, so I can't explain very quickly. The code is really usable. We have most of the code in libraries, so if anyone wants to write another application similar to boxes in another language or something, they can do so using these libraries. It's very stable by now. There's lots of users. I bumped into users of it in in pubs in London. It's weird, but it happened. True story. Accessible, it's very accessible. And we had some improvements about it in the last cycle. We'll have more, of course. It supports something called snapshots. So if you have a virtual machine with, for example, Fedora on it, and you wanted to upgrade to Fedora from 18 to 19, for example, and you're not sure about it, so what you create a snapshot of that time of the machine, and then the whole state gets saved. And then if you do an upgrade and everything goes south, you can just revert to a snapshot. Like in this, you can see I have a RHEL 7.0 virtual machine, and I have some snapshots for it, and I did some upgrades, and after we did some before upgrades, I did snapshots. So I can revert to them at any time, and I can manage these snapshots easily as well. We now have support for multi-window, so you can run multiple VMs in multiple windows, and we didn't have this before, but it's a cool thing to have. People do that with virtual machines. They want a separate window for each of their VMs. That's how it looks like when you run multiple windows in multiple windows, multiple virtual machines. Yeah, thanks for listening.
No live demo?
What?
Live demo?
It's someone else's computer, it's Windows. I don't know how do you get out of
Press escape.
I did.
Not it's Windows. So, thanks a lot, Ali, for your talk. Now we are going to have a really nice talk called Using Free Software in an Ordinary IT Education by Bastian Ilso. Did I pronounce it right?
Yeah, something like that. It's fine.
Okay. You can, yeah.
Okay, I'll take it on. It's okay.
You could use your own computer if you feel not comfortable with Linux.
Take your USB stick.
There should be a VGA port somewhere, I think.
There's a VGA cable down here.
You can use that.
Let's try this.
Yeah. So,
I don't know. Can I like?
yeah, you can remove the please try not to touch things you're not supposed to do.
No.
Okay.
Oh.
So, next speaker is going to be Eva. ¿Sí es cierto? Is she here? Ah, yeah, there you are. Be prepared for the next talk so we can go as fast as possible. Wow. She can do amazing things. I wish I could do that.
So what does this mean?
Hmm?
It should be on now.
Okay, but is it not? Let me check. What about now?
Yes.
Yes.
Here we go. Okay. So I'll do like this.
Ooh. Keep it neat like this. Go.
Okay. Hello. My name is Bastian, and I'm an IT student from Denmark. I study something weird called mediology, and we're basically trying to solve like various problems in society by using media technology. So that's basically like graphics, animations, and interaction design, and that's all the different things just kind of combined. And then the interesting thing about it is that each semester we sit in these groups. We are 6 to 7 people, and then there's me, who sits there at the bottom with Linux, and I'm trying to cooperate with these people using free software pipeline. I don't know if you have tried to do that. It's interesting. So it's a lot of groups who do this, and the whole study is right now quite populated by a lot of Windowses and a lot of Macs, which is fine. What I do is I just try to push for whatever works cross-platform, and if possible, try to push as much as possible for a free software solution. And with these two criteria, I can get the whole basic project management and collaboration working, even within graphics and stuff. Some things work well, and some things work as well. There's some fields I would like to push a bit more than others. I'm not very good at this. So things like Git, Blender, and LaTeX seems fairly popular among the students at my study, at least. And it's some very nice projects that has some people are aware of the existence, and that's very nice. But on the other hand, we have a lot of students on my study who use things like freeware cloud services that has proprietary clients and proprietary office suites, and these industrial standard applications that we also get lectured in for example, graphics, and IDEs as well, and also game engines, which is sometimes a bit sad. So I think, like for free software, something we do well is that when we create like a free software application, we're pretty good at keeping it very like cross-platform and available for people. And usually we also have quite a decent amount of features. I create promotional videos for GNOME, and that requires animation, graphics, and image manipulation, and all these things. And I feel I have the tools I need. But I think the core obstacles is that some of these tools are not always as stable as the proprietary alternatives, and I think what also blocks the most would be the documentation for the tools. I have some sample use cases I would like to show you. So first semester, I tried to use FileShare. I kind of pushed my group into, let's try this FileShare thing instead of Dropbox, for example. And it seems like a really nice alternative. Like they sell it very well on the website, in my opinion. But sadly, this was one of the cases where the stability came into the picture. The Windows client crashed all the time. So that was a bit sad. The second use case was that we had to find a game engine for our semester this year, and we looked into a free C++ engine, and we found something called COS, which is open source as well. But sadly, this one lacked a lot of documentation, and we were quite new to coding, so we also had to ditch that one, unfortunately. And the third case is Git, which is, I don't remember why I put this one up. Well, I don't know, I think this is where the awareness comes in. A lot of the students know SVN, but when they try Git, they can also see, oh, it has good documentation and it works. But it's just the awareness part that the fact that it's not pushed as much at the university on my study as, for example, SVN. But I also have some stories. For my second semester project, we used Arduino processing and Eclipse to create our product, which was this fancy prototype table that was supposed to help students get more social with each other through a game. And for my third semester, which is on right now, we are doing this funky sketch, which is basically a table game that's supposed to help primary school pupils to learn programming using OpenCV and basically creating multi-touch with that. So to sum up, I think like doing code freezes and making sure the software is stable is a really important thing. We should also write some more documentation. And then we should also keep spreading the word about these cool free software projects so we can push them even further down the education, etc. And that's it.
So, now we have Eva Siesjerne over here, who is going to give us a talk with the title Arctic Children and Digital Literacy. Am I right?
Okay, thank you. And well, I'm associate professor at Tromsø University, and this is what I'm going to tell you about. Is our joint project in the Barents region that involves Sweden, Finland, North, West Russia, and Finnmark in Norway. And it's a project which was called eHealth, and how to promote health through internet. And well, this was a troublesome thing, because what they wanted to do is to see how proprietary software would make children happy and prepared for their life in the future. And of course, you might understand I ran into problems. How would you interpret eHealth? So I'm a psychologist, and I started to think what really makes you healthy is to manage your own life. And well, we were in the research methods we used was a questionnaire for all countries, and we also involved through my colleagues Moscow and Yakutia, which is a very interesting. Sakha Republic is bigger than Brazil, with 1 million inhabitants, and mainly indigenous people. So the result of our research questions, and we also combined with qualitative research and interviewed teachers and parents. And what we discovered was that the knowledge of what's really going on in about the struggle of dominance of internet, for example, nobody knows anything about it. And also, it became so obvious that the municipalities are kind of captured by Microsoft. So what the school authorities think is preparing the children for a digital future is to use apps, to put your documents in the cloud, to use Dropbox. The children use the computers for downloading music, search on Wikipedia, that's the good thing. But mainly teachers don't encourage using Wikipedia, because everybody can go there and it's very untrustworthy. And I tried to argue that this might be a misconception, although this is the overall attitude from teachers. So they have a very limited, they can download music, they can Netflix, you know, all those proprietary things. They go on YouTube, they play games, and that's about it. Nobody knew about the possibilities, for example, using the MIT products in children's programming, like Sugar on a Stick or Scratch, or those. And I even tried to show some of the children, but they have got tablets, iPads, and we couldn't download a Scratch program. And people really didn't understand, nor did I. I'm sorry, I'm not so clever in those things. Although I know that I'm very worried about this future. And I'm about to write some articles in for the journal in digital literacy in Norway, arguing that school authorities in all our Scandinavian countries have to rethink what they believe will be to prepare the young generation. Those were secondary school children from 13 to 16. And to prepare them for a digital future, they really have to rethink from computer literacy into computational literacy to really know what's going on. And the health aspect is really, you need to have control over your life. As it is, you are outsourcing the very essential things in managing your life and your future is outsourced to Microsoft and to Apple. So, thank you. And you are welcome. We would love to have you visiting us. So I have to have your card and see if I can get some money. You might think it would be nice to see the Northern Light and things like that. I need voluntaries. I'm going to look for the money.
Yes, I'm a Debian developer involved in the Debian Junior project. And maybe you've heard of School of Linux?
No, I have heard of Linux, but
yeah.
you are doing things on
Yes, so I just want to connect you and we'll talk afterwards.
Great, thank you. And anybody else? So, yes, we have to exchange.
Yes.
Thanks a lot for your talk, Eva. Really interesting topic, working with software with people that have no idea. I was doing something like that in Spain a long time ago. Strangely, people would play Windows. Idiots. So, is here Carlos Martin? Please come here, come on. Out of curiosity, are you Portuguese, Spanish?
Spanish.
Ah, pues nada, venga, ven para acá, hombre. No podemos. So, are you going to use your own computer, I suppose?
I'm going to use his, because his has a VGA port.
Okay. Just be careful with this keyboard. That's a piece of chalk, don't worry. So, go. You know, if you upload your presentations somewhere on the web, we can download them. If you have demos, then it's a more problematic thing here. So, well, once you get the output there, it should start working. So the talk is called Lead Git 2, Programmatic Access to Git Data. Why Lead Git 2?
So that's perfect. Let's the second slide. So basically, Git has this shell API, but it's okay. So it has this shell API, but when you're using a programming language, you then have to parse all the data, and it's really error-prone. And then it's sometimes there isn't even a stable format for output, so all you can do is just run some command and then good luck passing. And then the presentation. Yeah, so we took some of the people from Git itself when they realized that the Git code itself couldn't be used. I'm just going to ignore that. Yeah, so there's there's a bunch of code in Git which is very useful with, for applications which aren't just shell scripts. So as soon as you have something complex that where you might not want to use a shell script, you don't have the problem of passing all this data. So what we give you is access to data structures. We take care of all the Git stuff. We don't call to Git because that also gets very slow eventually. And then we take care of everything. We give you data structures and we give you all the data that you need. We also give you the lower level data than Git sometimes does. So it's portable C, and even Microsoft, like the Microsoft compiler understands it, which is not true for Git all the time. We also have zero dependencies as long as you don't want to use encryption, because encryption we're obviously not going to use our own. But I am working on a way to abstract away the need for OpenSSL. This is a really terrible library. But if you you go to the next one. Yeah, so the what I've spoken about before, that some bits aren't even machine readable. Like if you run a fetch, there is no way you can predict what's going to come out. So we provide that, so that you can, yeah, and we do provide like more fine-grained information than Git will in any portable way. And so the why we usually Git 2 rather than just right. So Git has all this code or some of this code already, but it assumes a lot of things. It assumes it's a program you're calling from your command line. It's single-threaded and it's running for like half a second and then it's going to die. So it doesn't go to free memory. It notifies global shared data. There's like 3 bits which are parallelizable, but if you want to access 2 repositories at the same time, you need to fork or shell out twice. And while there's the cgit repository viewer which does this, there's some code which sometimes get deleted because it only exists because of this program, which is external to Git. And so we do provide the API that says, right, this is a problem, this is documented, this is what you can do. So then, yeah, basically you say, well, yeah, C is really stupid, and I can agree. So we have bindings for basically anything you want to do. There's the 3 big ones, which are basically the main ones which GitHub and Microsoft uses, so they have resources to put behind them. I'm rewriting our CI scripts to use Python, so it's been a great help. That we can change like several hundred lines of shell script and pass them inside the shell script as well, with just a few function calls. And then, yeah, so we have also like the sort of big people using, like the Plastic SCM use cases, because they're a different version control system, and they use libgit to talk to a Git server, and then they basically pass out all the data, and then they convert to the local format, so they can still keep their users happy with their UI, and then they can talk to GitHub, for example. So this is where you can find us. Just search libgit 2. It's semi-permanent. The big repository is on GitHub. That's where you have like the Stack Overflow. And one other user that we have is Subversion. I don't know if you heard about the April 1st joke, or maybe not so much of a joke now, where they were saying that Subversion was making into Git. So we actually, or mostly him, he made the Subversion checkout from Git. So yeah.
One simple question.
Yeah.
Is it like a wrapper around Git command line, or you read the...
No, there is stuff like that, like Git Python, but so that's the equivalent of doing file system access by calling ls with different arguments, right? So now we pass the Git data.
Hi, so I'm Stefan Sperling. I'm working with Carlos at Indigo, and I'm doing subverted stuff there, like more conservative things that he does. And when the subverted project decided to migrate to Git on April 1st, they filed a ticket with the ASF infrastructure team to please migrate the repository data. And people were, of course, outraged that we couldn't be using our own code anymore. The actual subverted project would not be running subversion. And so the proposed solution for that was a change to the subverted binary that where you see down here, you see a new repository access module that implements the Git URL scheme. And for me, this was a great, like, apart from the joke factor, this was a good opportunity for me to dive a bit more into Git and how it works and try libp2 and discuss some API stuff in libp2 with Carlos. And if you hold the mic, I can actually demo the working client. What URL do we have here? So I used the Git protocol, get it from a public site, so you see that I'm not lying, and here's your.
Yeah.
Maybe I just.
Yeah.
Okay, so what's happening here is that subversion is basically, I don't know what sparks and such doesn't matter. So what this does is it gets a clone of the Git repository into the working copy of the subversion client, which is hidden in the .sbn directory. So in addition to the usual stuff you see there, you see the Git repository, which is their repository. And what we do is, on that repository, we perform a first parent traversal of the history and map this to subversion revision numbers. And so whenever the subversion client wants to access something on the server side, it gets hooked up into libgit, which will then find the right tree to get all the data out of based on the commits that it finds on this mapping. And we got as far as implementing update and status and diff and all that stuff works anyway. And commit we know how to do, but we didn't get it done by April 1st. So this is just to show you that libgit can actually be used inside your applications.
Yeah, and that's basically it. Thanks, so check out the website and see if you can use it in your applications. Thank you. Wow, with some reason you managed to get it to working without getting crazy. It used to be known as contact percent before. So now we are going to have Ragnar, can it be? Ragnar, however you pronounce it. Free software in scientific computing.
Ragnar.
Yeah, Ragnar. Ragnar. Okay, Ragnar. Is that person on here somewhere? Okay, if you guys see him coming, please tell him to notice me so he can go and give his talk. So instead we are going to have APRS position tracking in search and rescue by Oyvind.
Yes.
So Oyvind eller Oyvind? Huh? Pronounce it yourself. Also,
Yes, can I use this computer?
yes, if you prefer.
Maybe the easiest way, actually.
That depends on how Windows lucky you feel today.
It's Windows. I'm sorry.
Sorry?
It's probably the quickest way.
Yeah, just connect a laptop here or whatever you need.
This is online. It's on.
Yep.
Maybe I can demonstrate as well.
It
Has OpenOffice?
contains Microsoft Open Office, which is not open, but
Then I'm not sure.
it might be able to open the file. That depends on how lucky you're feeling.
I don't know if it will work. Cross fonts, etc. Let's see. OpenOffice. Yeah.
Wow, it contains Open Office.
Yeah.
Hey, Leif, your AT administrators know how to do stuff.
Very okay.
If they only added the icon on the lower part, it could be better. Yeah, just see. I think that's it. Yeah. Whatever. Give me a second. Hello, Mr. Lowell.
Oh.
And Larry, I just going to catch you for buying.
There you go, Mr. Lord.
Yes, let's see if it starts.
Well, it says on Acker, so it's not that old.
Okay, okay.
A lot of light.
Isa.
Keep the microphone in your mouth, and point it towards your mouth a little bit under.
Yes,
Like that, perfect.
then you hear me. Yes, I have been here before and talked about this a couple of years ago, and so maybe some of you have heard about this. Yes, I'm an associate professor at National University College today, and I'm a ham radio operator, you know, radio amateur, and most of this work is done as a radio amateur actually, so therefore it is interesting. Yeah, so hams are actually contributing to search and rescue services in Norway, along with Red Cross and other voluntary organizations. So we have done some interesting things about tracking. So what about emergency situations and things like that? What's characterized those kinds of situations is that the organization is rather ad hoc, and it involves multiple agencies, different organizations, they collaborate. There's voluntary efforts, and it's very important for the leaders to coordinate all those resources and to get a picture of the situation. Get a picture. Yeah, they need to see what is going on and decide according to that. And that's where we can come in, both in communications and in showing a situational picture by using tracking and presenting on a map. It's kind of GIS rules we use here. It's well known that GIS tools is very useful in that kind of situations. Yes. And we focus on tracking actually the personnel which are going out in the field for their safety. Yes, the tracking system. Actually, there are trackers which are GPSs and transmitters. We have repeaters. We have gateways to the internet. The positions are streamed actually onto the internet, received by clients or GIS servers, which is my focus, and presented on the map. Yes, this is, we actually designed a tracker, so this is kind of open hardware project, but I won't talk about that now. It's very interesting to see how we can do that as radio amateurs, and we could design a complex thing like that. Yes, my contribution is the Polaric server. That's the name of it. It's a server solution based on Apache, Linux, but it runs on Linux, PHP, Java, etc. Many languages, many technologies. Lots of open source components there. For example, open layers is very important to handle map data. Anyone knows open layers, for example? Yeah? GIS tool. It's web-based, and the idea is that clients to these systems shouldn't need anything else than a standard web browser. So it's easy to use, it's easy to distribute out to different users. So it's a server solution, and you can do things on the server, like adding information, changing how this will look on the map, and everyone will see that. It could be a different agency, it could be the police, it could be Red Cross, actually using this system. Yes, and it has been extremely important that Norwegian Mapping Authority has opened up their data. So the fact that we have a free web mapping service here is essential. And last year they actually opened up raw data, some of it at least. Not only the map images, but also some of the map data. So that's interesting trend, actually, that data is, public data is opening up and we are using this. There are also all other kinds of data that can be exploited here, like road data, roads, positions of important things, yeah, dangerous areas, things like that. Yeah, so the idea is that we can combine different kinds of data here. We have done some of it, but not everything. And it's also interesting that the servers can be mobile, and we can bring a LAN out in the field where the command center is, for example. And there's often not a broadband connection to the internet, so we need to cache map data, for example, or store it locally on the server to have to be able to do this. Yeah, and we can synchronize server somewhat by using radio. The APRS protocol can be used for that, using a kind of peer-to-peer protocol, for example. There's lots of things there. An example of how this is used, this is actually a search for a person which was probably dead already. Now it's a murder case near Tromsø in Norway. We see different teams are walking like along the river up in the mountains there. So we can see at real time what's going on, and that's very useful.
1 minute.
Okay. Here we see how if you can search for the history a little time back in history, what has been going on in the past, and you can see where the search has been. And this is also a search for a body. It's also a murder case, actually. It's tragic, but this is a real thing I'm showing here. Also in Tromsø, a couple of days ago, actually, this picture. So the police actually asks for this when they need help from voluntary organizations. So that's interesting. I want to. There is lots of ideas here how to develop this further. This is work in progress. You can maybe look at this yourselves and see if it's interesting. For example, I'm working on a spatial temporal database based on PostGIS to actually be able to search what's been happening in the past. Being able to embed this application in other applications can be interesting. Being able to use OpenStreetMap, for example, in the system is interesting. I'm actually working with this just now. Using different kind of data. We are going to work with Nødnett, the Norwegian emergency network. Yeah. So, and also using hardware like the Raspberry Pi, or this is the QB board. Yes. So, but that's it. So,
will you give 15 seconds to summarize what is it?
Yes. It's just this. This is I use OpenStreetMap and plot my position here at FSCONS, just to demonstrate what's going on just now. And you can look at this at an open service, aprs.no.
Sadly, late Göran is postponing his start for tomorrow. We are still not done. We are there are more talks if you are interested. Anybody has seen Ragnar? This is last call for Ragnar. Ragnar? No Ragnar? Okay, no Ragnar. Whatever. Your turn, Tobias. So, Mr. Tobias Mueller is going to speak about something amazing as non-case signing OpenPGP case easily.
Yes.
Not that signing OpenPGP case is hard, but using it is. We are lucky Werner is not here. Otherwise he will be really angry at you.
Lovely. Hello, everybody.
You have 10 minutes.
So, start the thing. So, who of you has got an OpenPGP key?
What?
OpenPGP key. Who of you does have one?
I have one.
Well, almost all of you. Awesome. Who of you has ever signed anyone else's key?
I have.
Well, it's getting less. Who of you, well, liked the experience?
I need.
Right. 3 people out of 20 or so. This is what I expected. And it's a dreadful experience. I've been to, well, several key signing parties in my life, and it's actually, I think it's a shame. We're mumbling hexadecimal, imagine that, hexadecimal characters, like as a fingerprint of a key. We have like so much technology at our hands, we're not using that, and we could do so much better, but we don't. Let me try to get this over. Right. So, what have we learned back in the day? Do not use short fingerprints, right? Because you could easily fake short fingerprints. Use long fingerprints instead. So we're left mumbling these fingerprints to each other on key signing parties, and then I've probably like written them down on a piece of paper, right? And then I'm at home, I'm trying to decipher whatever I've written back in the day. And if I'm lucky, I get the correct fingerprint. And then I press enter, and well, it imports the key. And we just hope that the connection to the internet was just about right, and that the key server we are connecting to was not malicious, so that we get the correct key. Turns out in this example it was not. Well, why? Because we have a fake server running, and this fake server does actually nothing but dump a malicious key. And OpenPGP, or GNU-PG in this case, does not care at all of the thing that we're getting from the key server. And it's just ridiculous. I mean, we're depending on key servers, we have so much infrastructure that we're depending on. It's, well, it should be forbidden, really. So key signing parties, going out to the internet to a key server is absolutely no-go. You should not do that. You must not do that. But what do you do instead? Well, nothing, right? Because key servers are our infrastructure, are core parts of our infrastructure, and we depend on that. That's just, well, insane, actually. So what do we do instead? Let's have linked local network, right? We have 2014 already. We have the Wi-Fi. We have everything. But we are not leveraging that technology for our key signing needs. So there's a simple tool, which is very young. There has not been a release just yet. So, well, the code is very immature, and, well, there's many bugs and all. But I hope that this will make our lives much easier. So this is some GNOME key signing, and this is the interface. You can select your keys, like one of your keys, and you go through, and you get, well, sort of this interface. And this is what Bastian will have done by now, I hope. Have you?
Yes.
Also, you can see he's turned his computer into one of those things. So I press this button, and hello, internet. So Bastian, we will now, our computers will now connect to each other. Boom. We've transferred the key securely, and the QR code is authenticating the connection, and the data will be transferred securely. And we will press next, and boom, there's the sign key. Following best practices, that's another problem. How do you sign a key? It's actually, when you follow the best practices, you can actually not do that with the open PGP client you have with GNU-PG. It's hilariously complicated to properly sign a key. This does that with a click of a button. That's the idea, at least. And, well, it does. And it, well, pops up your email client and you can just, well, send it off. So, let me bring up the browser here. Turns out, my attack that I've just demonstrated with GNU-PG, well, it's a bit lame because GNU-PG 2 will actually, well, sort of prevent downloading a malicious key. But this one, this is an attack. You can download this script. It will generate a key with the correct fingerprint, but, well, with, like, fake data, right? It will provide a malicious key with the correct fingerprint, and your GNU-PG 2 will happily import this. So, my attack was lame. This one is more elaborate. You must not use key salvas. That shall be the gist. And, well then, you've been to a key signing party, right? You're all the nerds and all. Who knows this? 1, 2. This is CAF. This is the pinnacle of key signing. This is what humanity has brought us so far. And this is how you configure it. It's Perl. It's raw Perl. I've sworn 3 things to myself in my life. I will never use Apple products. I will not go to the US, and I will not write Perl. And this is the configuration of CAF. It's raw Perl. We must not do that. That's just insane. So this is, the, as I said, the pinnacle of key signing. This is how you do it. And this must not be the case. So we're trying to do this much more smoothly through the key signing project. It's, well, it's a GitHub away. There's the README, there's a few, well, installation instructions. It's very immature, as I've said. Patches are very welcome. The UI needs a redesign and all. But I think this is the right way, and I invite you to use that tool. Thank you.
When are we getting this nice piece of software?
Well, you can get it right now from the internet.
Right.
So, I think there is only one tag left, unless Ragnar appears. Ragnar? Anybody has seen Ragnar? Okay, if you know who is Ragnar, please make sure that he's alive. I mean, maybe he got lost in the forests out there or something like that. You know, elves can be really dangerous creatures. So, my tag is about code obfuscation. It's titled Obfuscating LLVM for Delaying One-Day Attacks. The idea is that, well, you will get ideas on just wait a second. If you guys are ever ODP, yeah. Thanks. Yeah, not object-oriented. Why do they put these things in Swedish? I think they don't want us to understand. So, this is basically a fast presentation on my master's thesis, which is being supervised by Jonas and Andre. And what's a one day? Well, a one day is simple. There is this guy called Microsoft that releases a new patch to fix this vulnerability that Blaster has been using during the last year. And, well, then somebody reads the code that has been fixed, sees what is the problem, and then we have success. That's basically a one day. What's the first problem we have when combating them? Well, compilers will generate the same code for the same input. It's, well, do you know what determinants means? Is what it makes that your computer works. So the amount of change that is introduced when you change a small part of the function to fix, for example, a vulnerability is small. Well, we have pseudo-randomization! Ooh. The idea is that the code generated is going to be generated taking decisions that are made by a pseudo-random generator. So as long as you use the same seed, you will get the same decisions, but if you change the seed, you get different decisions, so you get different code. The second problem we have is that the code can be still reordered, because we are mostly doing reordering decisions, to find which is the real change that were made, and thus focus the attack on, or the concentration on that code. So yeah, attackers know where to look at. Well, that's why we use obfuscation. The idea is that we generate code automatically that is harder to read and to understand by humans. And since we are also randomizing the code, it's almost impossible to go back to the original source code. And yeah, in my master's thesis, there is an explanation on how to revert the techniques, but you can use more advanced techniques if you want to implement them. And yeah, that should be problem free. Well, mistakes happen. Patches should be small. I mean, you want it to be distributed as fast as possible. But yeah, if you use these techniques, you would just change the whole thing every time you compile. Nah. So we use obfuscation keys. What's an obfuscation key? An obfuscation key is a function attribute that will tell you how you have to initialize the pseudo-random number generator. So, if you use the same obfuscation key, you get the same code. If you don't use any obfuscation key, you don't get any randomization or any obfuscation. If you change the obfuscation key, you get a different code. So, before I go to how is LLVM blended here, there is a missing slide here. So, the idea is that basically you will pick some functions, you will generate an obfuscation key generated randomly for them, and then you will just compile the whole thing. And you will have a bunch of functions instead of a single one, but it will have a limited size. So you will be able to focus. You have a small patch where let's say, for example, if you pick 200 functions and they are obfuscated, it will take a longer time to figure out what to attack than if you just pick a single one, which is the current case. So how do we blend LLVM? Well, as I said, obfuscation keys are function attributes or compilation unit attributes. And we use the optimization engine in the middle of everything. So yeah, our obfuscation techniques are called optimization passes, despite they actually make the code slightly slower. So not exactly optimization, but well, it's what we could use. And yeah, the middle code, the very thing is that with LLVM we can, for example, compile 10 minutes. We can compile ADA to x86 and C to, I don't know, let's say, for example, an ARM processor. And we will be able to do the obfuscation using the same parameters because we will still be working on LLVM middle code. So here is a simple CLAN asset example of how you can use all this stuff. You first compile the code using CLAN and you might intermediate code. Then you use op, so you will call the randomization and the obfuscation transformations, loading the obfuscation library, and then you use compile, which LAMP the resulting intermediate code. Yeah, I know, it's ugly like hell. Maybe for release 2, when I am done presenting my master's thesis, I will present something better. This is the reality. Now you can run away. Yeah, that's basically what nightmares are made of. But if you check the important part, which is with op and the other part, you will see that what we are doing is just adding a module key, which will affect all the elements of the compilation unit. Then we are propagating the module key to the functions. Then we are using some different transformations like UV split, control flattening, constant obfuscation. If any of you has worked on security, these things you see every day on fucking viruses. We get tired of seeing it. Yeah, and well, run-beans, run-BB, run-fun, run-TLB is basically the randomization transformations, which we apply after obfuscation. And finally, swap ops, it's basically swapping operands randomly, so you get a little bit more of mixing in the mix. And that's it. So, I asked for questions, but for that we have the cafe. There you have my master's thesis. If you want to read more, you have the code, so you can try it by yourselves. Please do. Please come with any input you want, preferably before my master's thesis is presented. And that's it. So, yeah, that's it. Now, before everybody goes, I'd like to make some small announcements.